Welcome to the second part of section 9.2. We're going to convert between degrees and radians, and hopefully you watched that great video explaining what exactly a radian was. I'm now on page 471. If you can just copy down the core concept, this is how we're going to convert between degrees to radians and then radians to degrees. Okay, so it's always going to be pi over 180, that's what we're going to multiply, or we're going to multiply by 180 degrees over pi. Okay, and let's do some examples. I am doing monitoring progress 9, 10, 11, and 12. Okay, so what's really important to notice is that you know that it's a degree because of this sign right here. That's a degree sign. If it does not have a degree sign, it will always be a radian. Most of the time, radians will have a pi symbol, like this one here. But this one does not have a pi symbol, but it also does not have a degree. So, since it does not have a degree, that means this one is in radians. This one, because it has a pi symbol, is in radians. And these two are in degrees. Okay, so if you remember, you know that 180 degrees equals pi. So let's think about this. If I have 135 degrees out of 180 degrees, I would like to know what that is in radians by multiplying it by pi. What the formula does, it's really taking 135 degrees, and you're going to multiply it by pi over 180 degrees. The degrees actually cancel out. It's over 1. So you're going to take your calculator. You're going to put 135 over 180. It's going to give you a decimal, but then you're going to you're going to use math frac, and it's going to turn it into a fraction for you. And you're going to see that when it turns it into a fraction, this is going to turn into, let me do it on my calculator, 3/4 pi. Okay, so let's do it again right here. We're going to take negative 140. You're going to multiply that by pi over 180 degrees. Remember, the degrees cancel out. We're changing it to radians now. You're going to put negative 40 divided by 180 in your calculator, and you're going to press math to fraction, and it's going to come out to be negative 2/9 pi. Okay, now we're going the other direction. So this time we're going to multiply this by 180 degrees over pi. So what do you notice? What's going to cancel out? The pi's are going to cancel out. Perfect. And again, you put it into your calculator and your degrees is left, and it comes out to be 225 degrees. Now remember, there's no degrees here. That means it's radians. So I'm going to multiply this by 180 degrees over pi. You're going to stick all this math into your calculator, and it's going to give you an approximation. This is in the hundredths, so the approximation is going to be about 359.82 radians. Don't put the degree. Okay, perfect. Let us move forward. We're going to do the next core concept, which is arc length and area of a sector. So I need you to please copy down the core concept here. And it talks about, I want you to think about it as a pizza. So the arc length is the piece of the pizza's crust. So it's here on the outside. So this part would be the crust. The sector, which is the area that's inside here, would be like the pizza part. All right, so here are the two formulas. The arc length, which is S, it's right here, is equal to the radius times the central angle, which is theta. Okay, so right here, the arc length equals the radius times the central angle. And to find the area of my sector here, it's going to be half the radius squared, again, times the central angle. So make sure that you copy that down. We're going to move on. If you want to follow along with us, we're going to do example 4 that's in your book. And I am on page 473. Okay, this is a great problem. A softball field forms a sector with the dimensions shown. Find the length of the outfield fence and the area of the field. Okay, so what they're looking for is they want you to find the length of the fence. So I'm going to highlight it here for you. They want to find this portion right here. Okay, and then they want you to also find the area of the field. I'll highlight it here in green. Okay, so this is the sector area that's all inside here. Okay, so first thing we're going to need to do is we have to take this 90 degrees and we have to convert it to radians. Okay, this is degree. And remember, the degrees need to cancel out. Okay, so we're going to multiply it by pi over 180 degrees. The degrees cancel out. And it comes out to be pi over 2. And your calculator probably said 1/2 pi. Those are the same thing. All right, so once we have that, now we can use our formulas. Okay, so we're going to make sure to go back and look at your formulas. Let's first find the arc length, which is kind of like the pizza crust. And in our problem, it is the fence on the outside. So that's going to be S is going to equal the radius times theta. So S is going to equal, what's my radius? Well, it's this length right here, which is 200, times theta, which is going to be pi over 2, because we converted it up here. Right? Cancels those out. And the area and the length of the fence turns out to be 100 pi, which is approximately, when you put it in your calculator, 314 feet. Okay, and lastly, let's find the area of the field. So it's, again, the formula, 1/2 radius squared times theta. Okay, so it's 1/2 200 squared times pi over 2. Okay, which turns out to be 10,000 pi. And that is approximately 31,416 feet squared. All right, so if you like, Mr. Mitchell, the next video is Mr. Mitchell's, and he's doing problem number 28. So why don't you guys try number 28 on page 475 and watch Mr. Mitchell's video to check your work.